Hi everyone, welcome to Drawing Hub. So this is Computer Graphics and Image Processing Module 1 Part 9. So in the previous video we have started the introduction of line drawing algorithm, and in this video we will be looking DDA algorithm, that is Digital Differential Analyzer algorithm. Digital Differential Analyzer algorithm. So now this Digital Differential Analyzer algorithm, it is a scan conversion line algorithm based on calculating, you can write this, based on calculating either delta y or delta x using the equation. So what is the equation? 3.4 and 3.5. So that is delta y equal to this equation. Delta y equal to m delta x and delta x equal to delta y by m. That is the equation that we got from m equal to delta y by delta x. So using that, how do we convert it? We can calculate that is we can calculate delta y and delta x using the formula m equal to delta y by delta x. We can just rearrange it and get it. Now we sample the line at a unit interval in one coordinate and determine corresponding integer values nearest the line path for the other coordinate. So consider first a line with positive slope. Okay, now 3.3. 3.3. Okay, over here. Now this one is the slope like we have x1. This is x1, y1. This point is x1, y1, and this point is x2, y2. Okay. Now we sample the line at unit in. Okay. Now if the slope is less than or equal to 1, we sample at unit x. So if it is less than or equal to 1, then in this case we sample at unit x intervals. That is, we will take delta x is equal to 1 and compute each successive y value as. That is, we will take delta x is equal to 1 and then we will put yk plus 1 equal to yk plus m. We will use this formula. Now the subscript k, this takes the integer value starting from 1. We don't take 0, we start from 1 for the first point and increases by 1. Sorry. Increases by 1 until the final endpoint is reached. Since m can be any real number between 0 and 1, the calculated y values must be rounded to the nearest integer. For lines with a positive slope greater than 1, so this one was for lesser than or equal to 1. Now for greater than 1, we reverse the roles of x and y. That is, we will take, in the previous case we took delta x equal to 1. So here we will take delta y equal to 1 and calculate each succeeding x value, and then we will calculate the x value by xk plus 1 equal to xk plus 1 by m. So here for yk we use yk plus 1 is yk plus m only. But when we want to find xk plus 1, we will use xk plus 1 by m. So now this equation, that is this yk plus 1 equal to yk plus m and xk plus 1 equal to xk plus 1 by m. These both are based on the assumption that lines are to be processed from the left endpoint to the right endpoint. That is, only if it is going like this, from left to right. This is left, this is right. It should go like this. Now, if this processing is reversed, so that the starting end point is at right, that is, if it is not like this, it is starting from right and going to left. If it is like this, then how will we have? Then delta x will be minus 1. Delta x will be minus 1. And at that time, the equation will change. Here we had yk plus 1 equal to yk plus m. So here it will be yk plus 1 equal to yk minus m. Okay. Now when the slope is greater than 1, then when the slope is greater than 1, we will have delta y equal to minus 1. Again, negative value came. And then the sign changes. That is, it will become xk plus 1 equal to xk minus 1 by m. Only the sign over here changes. Now here 3.6 through 3.9, that is all these equations, yk plus 1 equal to yk plus m, and xk plus 1 equal to xk plus 1 by m. Then that is now for the negative value, that is when delta x equal to minus 1, that is if the direction is changed. Then yk plus 1 equal to yk minus m and xk plus 1 equal to xk minus 1 by m. So all these equations can also be used to calculate pixel positions along a line with negative slope. So if the absolute value of the slope is less than 1 and the start end point is at the left, we set delta x equal to 1 and calculate y values with the equation 3.6. So what is 3.6? This one. Yk plus 1 equal to yk plus m. Now, when the starting point is at the right for the same slope, that is we are taking delta x equal to minus 1 and obtain y positions from the equation, what is 3.8. That is using this equation, that is if the direction is reversed, the starting point is right side, then in that case, when the absolute value of a negative slope is greater than 1, we use delta y equal to minus 1. And equation 3.9 is about xk plus 1 equal to xk minus 1 by m. Or we use delta y equal to 1 and equation 3.7. So this algorithm is summarized in the following procedure, which accepts input as input the two endpoint pixel positions, that is horizontal and vertical differences between the endpoint positions are assigned to parameters dx and dy. The difference with a greater magnitude determines the value of parameter steps. Starting with pixel position xa, ya, we determine the offset needed at each step to generate the next pixel position along the line path. We loop through this process steps times. If the magnitude of dx is greater than the magnitude of dy and xb, the values of the increments in the x and y directions are 1 and m respectively. If the greater change is in the x direction but xa is greater than xb, then the decrements minus 1 and minus m are used to generate each point on the line. This is the code in C. Now, you can write till here, not this way. You can write till here. Equations you have to substitute what you are writing. So from there to till here you can write for DDA algorithm. Now the DDA algorithm is a faster method for calculating pixel position than the direct use of 3.6. Rather than using it directly, DDA algorithm is faster method. It eliminates the multiplication in the equation by making use of raster characteristics so that appropriate increments are applied in the x or y direction to step to pixel positions along the line path. The accumulation of round-off errors in successive additions of the floating point increment, however, can cause the calculated pixel to drift away from the true line path for long line segments. Furthermore, the rounding operations and floating point arithmetic in procedure line DDA are still time consuming. So it is time consuming. It is faster method, but still line DDA is time consuming. We can improve the performance of the DDA algorithm by separating the increments, that is m and 1 by m, if we separate the increments into integer and fractional parts, so that all calculations are reduced to integer operations. A method for calculating 1 by m increments in integer steps. We will have that in the next session. So this is about DDA algorithm. I'll go to the notes. Now, the scan conversion line algorithm based on calculating. So, DDA algorithm is based on calculating delta x and delta y using the formula m equal to delta y by delta x. We can find it. Now, the line should be sampled the line at unit interval in 1 and determine corresponding integer value nearest the line path for the other coordinate. This is a line with positive slope. This is a positive slope which is called an uphill. This is a negative slope called the downhill. This is slope equal to 0. Horizontal slope is undefined. Vertical. The assumption that lines are to be processed from left and end point to the right end. So from left to right, if it is going, if that is a direction, left to right is a direction, then we take the, and if the slope is less than or equal to 1, m is less than or equal to 1, then we take delta x as 1 and yk, we find yk by yk plus 1 equal to yk plus m. Now if the slope is greater than 1, then we take delta y equal to 1 and xk plus 1 equal to xk plus 1 by m. This is for left to right. Now this algorithm is summarized in the following procedure. Input the two endpoint pixel positions x1, y1, x2, y2. We are having two pixel positions x1, y1, x2, y2. The horizontal and vertical differences between the endpoint positions are assigned to parameter. We have dx and dy. Dx or delta x, that is x2 minus x1, and dy is y2 minus y1. So the difference with greater magnitude determines the values of parameter steps. Now starting with pixel position, we are taking x1, y1 determines the offset needed at each step to generate the next pixel position along the line path. Now loops through the following process steps. Now here we are looking the code. We are taking void line DDA, and inside that we have parameters of integer type xa, ya, xb, yb, and then integer we are declaring dx as xb minus xa, dy as yb minus ym, then we have step and k. Then we are also having float x increment, y increment, that are float type, then x equal to xa and y equal to ya. Then here we are having the if statement where if abs dx is greater than abs dy, the steps equal to abs dx, then steps equal to abs dx, else steps equal to abs dy. Now x increment equal to dx by float steps and y increment equal to dy by float steps. Then set pixel round x round y for k equal to 0. Okay, we are using a for loop. For k equal to 0, k lesser than steps, k should increment that. Then x equal to x plus x increment, increment x, and y equal to y plus increment. Then set pixel round x round y. That is the code for, and here I am giving input length between 2 to 2 and 6, 6, 2, 2 and 6, 6. Then the problem we will be discussing in the next video. So then bye bye.